Hi, this is Randal Schwartz, host of Floss Weekly. This week, Dan Lynch joins me. We're going to talk about music, specifically the Overtone package. It's going to let you be able to create music and sounds just by writing in programs. It's going to be really cool. You're going to want to see this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by Cachefly at CACHEFLY.com.
This is Floss Weekly with Randal Schwartz and Dan Lynch. Episode 197, recorded January 11th, 2012. Overtone. This episode of Floss Weekly is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. It's time for Floss Weekly, the show about free, libre, open-source software. I am your host, Randal Schwartz, Merlin@Stonehenge.com, coming to you each week with big projects, small projects, the big projects you might have heard of before, the small projects you might not have heard of before, like today's show might be something like that. But you'll want to hear about that, so stick around and talk about what the heck am I talking about. Let me just bring on Dan Lynch. Dan, welcome back to the show.
Hi, how's it going? Great to be back as always.
Apparently, it's going kind of crazy. I'm in a new location. If you're watching the video, you might see that it's not the normal studio setup that I have here. I'm actually in a hotel room on the east coast of the U.S. in Florida. I'm just about ready to do another one of those wonderful cruises that I spend so much time on. So I'm over here a little bit. If the video and the audio drop out a little bit, it's because I'm on my 4G card, too. So we'll see how well this works throughout the show. Dan, we have a really great show today. We actually have a music-related show. I know I've seen the notes already on it, but we've got Overtone, which is a project that is a highly expressive closure front end of the state-of-the-art real-time sound synthesis server, Super Collider. Have you heard about this at all? I know you're a musician as well, so.
Yeah. People watching the video might have been able to see that I've got a guitar somewhere down there. There you go. There's a guitar and a keyboard. I thought I'd bring those along today, since it's a music show. So that's not great for people who are listening to the audio. But I've looked at Super Collider a little bit. That's actually open source GPL licensed synthesizer. It's been used by people like Radiohead and stuff like that. So yeah, very cool.
It should be a good show. It should be a great show. But before we get to that, I have a very important announcement, which is that this episode of Floss Weekly is brought to you by Netflix. Netflix streams thousands of TV episodes and movies directly to you instantly, which means you save time, money, and hassle. There are several easy ways to instantly access streaming movies and TV shows with Netflix. You can watch Netflix movies and TV shows on your Mac or PC or iPad. You can watch on your iPhone. I do that as well, and some Android phones as well. If you have a gaming console like an Xbox 360, a PS3, or a Nintendo Wii, you watch Netflix right on your TV. I have it on my PS3, and it looks gorgeous on my PS3. And if you're not a gamer, you can watch Netflix on your TV with an Apple TV box or a Roku box. I have a Roku, and it works really great on the new Roku, too. They're inexpensive and easy to use. So with Netflix, you can watch TVs and movies instantly using any of these devices. And you can begin watching a movie or a show on one device and finish on a different one. Whichever way you choose to access Netflix, you can watch as many movies and TV shows as you want, anytime you want, and you can cancel at any time. So try Netflix today for 30 days for free. Go to netflix.com/twit. Be sure to use this URL when you sign up for your free trial, netflix.com/twit, TWIT. We thank Netflix for their support of Twit and Floss Weekly, and we hope you enjoy watching instantly with Netflix. Now let's go ahead and bring on our guest. Sam, welcome to the show.
Hello there. Pleased to meet you.
And where are we speaking? Where are you speaking to us from?
I'm currently in Cambridge in England.
So it's the almost all Brit show, except for me. I'm on the East Coast, though, so I moved closer to you just for the show, just so you would sound better to me instead of being on the West
lovely.
Coast.
It's so kind.
I know, it helps. It really helps to have this kind of close connection there. So I did a really horrible job of explaining Overtone at the beginning, so I really didn't do my research this morning. So could you give us sort of the 30,000-foot view of what Overtone is all about?
30,000 foot.
10,000 meter. 10,000 meters.
Oh, no, we do feet in England as well. We do both. We can translate.
Yeah, we invented them.
I guess that's a hard question, because you really need to have an idea of who I'm talking to. So are we talking to developers, or am I talking to musicians, or am I talking to people who are interested in listening to what's going on? So
I would say the answer is yes.
Of course. So the answer is Overtone is it's a philosophy in a way, and it's also a framework which adheres to that, which says that programmers, and it's our current audience is programmers. Programmers can trade in their programming skills for musicality, and this is the idea. And so it's a set of tools and a language, and a growing language, which allows you to harness your programming skills in order to make very interesting sounds, beats, rhythms, music, compositions, and noise in general.
Well,
I guess that's the 20,000 voice. Yeah. So the idea is, if you're a programmer and you like music and you don't necessarily, you haven't spent 10 years learning how to play the violin or the piano, but you've spent a lot of time learning how to program, you can trade in your skills and become a musician with Overtone.
Okay, well, that's a great overview. Now, how does it accomplish that? That you've got me already. You've got me intrigued. How does it work?
So,
because I'm a bit of a musician myself, and I'm also a pretty good programmer. So you've already got me intrigued. So tell me about this. There's
a lot of people exactly like you and exactly your position who have some musical skills or interest in music, who dabbled when they're young. I certainly dabbled when I was at school, but really didn't dedicate themselves to music. But maybe they dedicated themselves to programming languages. So there's a lot of people in exactly this position. And we achieve this in the way that all great things achieve great things. Not to say Overtone is great, but I'm hoping it will be, in that we stand on the shoulders of giants. So we leverage great other open source technologies to allow us to build a very robust and quite remarkable framework. And so we use there's two core technologies that we're actually using underneath the hood. One is something called Super Collider, which is a sound synthesis engine, which allows you to describe synthesizers, which are essentially mathematical compositions, sort of a directed graph of what's called unit generators. And I can go into more detail about that if you want. But essentially, you describe a kind of sound, and then you then interact with that synthesizer, or the multiple synthesizers you created, from an external entity. And in this case, Overtone is built using Clojure, which is a Lisp variant, which runs on the JVM, which has it's remarkably interesting concurrency semantics. And it's just it's a fascinating language to look at, and it fits perfectly within this domain. So we're using Clojure to communicate with Super Collider, and we're wrapping them all up together in one unit. Does that make sense?
It's sort of. Okay, so let me see if I get this
we
straight.
We should go into more detail, of course, clearly.
Yes. So I'm starting with, all sounds start with like something like a sine wave or a triangle wave or something. So through this system, I'm able to say, give me a sine wave at 440 hertz, which will be a nice middle C, and then do something with that, right?
Yeah, so that's one line of code. So what you could describe, the super simple demo, the hello world of Overtone, is to type in open parens, because it's a Lisp, demo, open parens, sine-osc 440, and that will play you a sine wave at 440 hertz for 2 seconds.
Okay.
But the thing is that description actually is a lot of moving parts that you don't see. So what that description is, on one hand, it's actually a description, a formal description of a synthesizer sound, which is the sine oscillator in this case. So it's a super basic one. It's also compiling that down to a binary format, shipping it to Super Collider, which then rarefies it, and then sends you back a function, which then you can call to trigger it. And it triggers it for you, and then after 2 seconds, it kills it. So all this thing is happening under the hood. But really what you're interested in is you're able to describe synthesizer sounds, in this case, a very simple sine oscillator, and then you have ways and means to control the sounds you've designed, so to trigger them and to modify them whilst they're in play. So, for example, your sine wave, you could describe the frequency as a control parameter, which means then later on you can send a new control message to say change the frequency to 660 hertz or whatever frequency you want, which will then change that note. And so if you can do that with a very simple thing like a sine oscillator, you can imagine much more interesting, complicated, sophisticated sounds which are generated from all sorts of different so-called unit generators, of which sine oscillator is one of 500 that Super Collider provides. So there's a really rich set of musical semantics or synthesis semantics behind the hood. And then you can control those in very interesting ways. So it then opens up the questions of, how do I design my sounds, and how do I actually effectively and have a good way of controlling the sounds so that I'm doing interesting things with them so that people will then call it music. Make sense?
Yeah, of course. So what's the interaction at this point then? So it sounds like I'm just writing a script that's going to generate tones, but am I also connecting like physical devices so I can maybe say, take this sine tone and control it by keyboard?
So people who are able to see the camera can see this, but this is called a monome. It's a box of buttons, and they all light up. As you can see there, look.
Okay,
to make it flash and things.
If you ever watch the video for this, you're missing out.
But essentially, it's a box of buttons which are also lights. Each of the buttons is an individual light. And so this is a very simple interface which you can actually use to do all sorts of interesting, sophisticated interactions. And so you can, by pressing buttons, you can actually, in closure codes, define the semantics of what that button means. So that might be to trigger the synth, or it might be to control the frequency of this other synth. And then you send the messages to SuperCollider, or Overtone does, to make the sound change. And so you're able to not just type in code to actually do this. Of course, I mean, the primary interface for me at the moment is Emacs. And I'm in a closure REPL, so I'm in a read, evaluate, print loop. So I'm typing some code, seeing the response immediately and being able to react to that. And so in this very interactive environment, I can type and manipulate the sounds. But also, there are obviously situations where typing a code isn't as good as actually pressing buttons or moving or waving your hands around. So you want ways to actually plug in external physical devices that allow you to communicate gestures to the audience you're performing to. In the same way, because if you think about it, one of the interesting things is to try and work out what we're trying to achieve with all this. So, I mean, it's interesting to talk about what Overtone is, and we're going into some technical details now. But it's also interesting to know what we're trying to achieve as well. And that's one of their goals is to try and make electronic music a performable art. So currently, it isn't very performable. Currently, you sort of render your electronic composition ahead of time. You go on stage and you play it back and maybe tweak some things. But most of the composition has been pre-rendered, as it were. You've pre-compiled it, to use computing terms. But you just got your WAV file, your pre-made WAV file. So Overtone stands its stance is initially that we want to actually improvise our music on the fly. And so we want to be able to have ways and means to directly manipulate the music, change our minds whilst manipulating the music, and to be able to perform on stage just in the same way that Jimi Hendrix performs on stage. And if you watch videos of Jimi Hendrix, often you'll see him playing his guitar with his eyes shut. And so you want to be able to emulate that kind of environment. So if you've got a computer and you're typing, you can't really type with your eyes shut and get a good experience. But you certainly could, with one of these monome devices, for example, you can imagine playing this with your eyes shut and feeling it, or waving your arms around, or using any of the many different kinds of Nintendo Wiis, or all sorts of interesting devices, or iPhones, where you can wave them around or press buttons. You can imagine building an interface that the audience can see you use, and to have some understanding of what the hell you're doing, which is I think a key component of music, because it's not just a sound phenomenon, it's a cultural phenomenon. And so it's about communication, about communicating to the audience what you're doing and how you're doing it, and then being able to perceive your virtuosity, as it were. So that guy, he's amazing on the guitar because I can see him wiggling his fingers crazy fast. That's really cool. Whereas if you see somebody in a terminal, most people haven't really got a clue what they're doing. Certainly most, I mean, I've seen a lot of musical performances where it's great sounds, but some guys twiddling some knobs, you've got no idea what they're doing. You don't really know if they're actually miming or they really are controlling the sound, or to what extent the control is. So I want to make that more visible. That makes sense.
Excellent. It sounds very, very cool. I like the idea of using Emacs to generate all this. I like to think that Jimi Hendrix would have been a wizard on Emacs if he'd ever got a go at it.
But that's only one of the ways to do this. I mean, you don't have to use Emacs. You can use just the terminal, or you can use Vim, or you can use TextMate. I mean, any closure environment, essentially, it acts as an Overtone environment. I just happen to enjoy using Emacs because I've got quite a pimped up Emacs config where it's flashing me possibilities and completions, and it's very nice. I like it a lot.
Oh, that is very cool. So I'm intrigued by the monome. I was actually looking into this today, watching some videos, and you're talking about the whole performance thing and people performing. There's actually lots of videos of people kind of almost playing them like a piano or something. And it reminded me a little bit of something like the Tenorion. Have you looked at that? I know that's slightly different.
It's exactly the same. Yeah. So the Tenorion is it's a Yamaha, isn't it? That make that. The thing about the Tenorion is it tries to be a standalone device, so you can sit in a park and play the Tenorion, and it's pre-configured with some programs to make music, so basic sequencers and little apps, and it's a nice toy, really. It's not something you necessarily would perform on stage with, but it's nice to play with. So the mono presents itself as pretty much the same kind of interface. And there's also the Novation Launchpad as well, which is much more readily available as a grid interface. But it doesn't give you any functionality. So it says to you, you need to plug this into a computer, and you need to write some software to tell it what to do. And you're in control of that. And I mean, what got me started all this, I bought this mono, I saw it, and I thought, isn't it cool that shapes could be chords? I mean, you're divorcing the means of making this. So with a traditional piano or guitar, the interface is constrained by the physical properties of the device. So the guitar has to have a chord of G, has to be like a certain way because that's the way the strings are. And if you want to play an F, it has to be. You have to define it in a way that the sound actually is produced. Whereas if you are able to divorce the interface from the sound production mechanism, you're free to choose an interface which is much more appropriate for the kind of music you're making. And so with the mono, it was cool to consider shapes as chords rather than weird things on a piano where you have to remember that black note is an F sharp and this black note there is a, stuff you have to remember. You shouldn't need to remember to make music. You just have to because that's the way the interfaces are today. But if we're in the ability to redefine our interfaces, like with the mono, we can choose something which is much more sensible. And so, yes, so that got me excited.
Okay. Sounds very cool. I was looking into this. I know you use the term open source music, and a lot of people, different people use that term to mean different things. So what does open source music mean to you?
A brilliant question. So I listen to lots of weird electronic music. And I love it. It's great, crazy sounds. And I often listen to music thinking, well, how the hell was that made? What synthesizers were used, what software was used, was able to lie? I have no idea. What interaction mechanisms were used? And I've got no idea. There's no way to find out. Perhaps maybe I might read on some interview with a particular artist that they used this particular software. But still, that's useless. What I really want to be able to do is to say, that's a really cool sound. What's the source which makes that sound? And so this comes to another goal of Overtone, and that's hundreds of years ago we had Western common notation, so the notes and staves and dots, and we were able to use that in combination with a printing press to distribute scores for orchestras to play. So suddenly everyone in Europe could suddenly make their own little orchestra and play the great works of the great composers because they were able to actually get printed copies of the music, and that printed copy was then able to be used to be studied, so people can still look back at those works and then reinterpret it and look into a deep depth. You can listen to an opera and at the same time read the score whilst it's being played to get more insight to what's going on. None of this is available with Aphex Twin's music or Skrillex. None of it's possible. And why not? So one of the goals of Overtone is to actually define a language or help start to define a language which allows you to not just notate note on, note off, pitch, which is what Western common notation does, but also to notate timbre, how the sound sounds. So you can and the idea then is to use programming languages to actually define an entire composition, not just about what's being played and when, but what sounds like and what the manipulations of the sound are, so that you can then download a copy of the source which made that composition. So for me, open source music is the same as open source. Like if I want to know how Apache 2 works, I can download the source and look inside. I should be able to look at, if you make a cool composition with Overtone, I'd like you to be able to put it on GitHub so I can download and look at it and modify it and learn from you, and also potentially remix it and mash it up and create something new out of it.
That's excellent. It sounds like it would fit in. I mean, obviously it fits in with the open source ideal and ethics and stuff, but it would fit in very well with Creative Commons as well, and that kind of the creative use of this open source idea.
Absolutely,
Yeah. So I was having a look earlier today into some of this stuff like Super Collider and stuff, which I've actually looked at before, but never actually used on my own system. And there's quite a few. We should probably talk a little bit about that. What do I need to run kind of Super Collider? Can I run it on any desktop? I mean, will it run on any platform?
Super Collider is almost another conversation itself, and that has a massive open source community, and it's very rich in a lot of academic work. Actually uses Super Collider, and we just use it as an engine. But it's important to say that Super Collider is actually two things. On one half, it's a real-time, or as close as you can get, real-time synthesis engine, which is capable of doing all the sophisticated synthesis. And on the other hand, it's also a bespoke programming language, which is remarkably like Ruby. And so you use the programming language to actually control and communicate with the synthesis engine. And so Overtone is actually replacing the SuperCollider language with Clojure. And so your question about SuperCollider, if you're asking about the actual vanilla SuperCollider experience, well, both the synthesis engine and the language are packaged as one unit, and it's available on all platforms. So it's totally fine. There's lots of tutorials for if you just want to play with SuperCollider language and to get to make some interesting synthesis sound. That's probably the easiest approach to take today because there's lots of documentation. The book's just been released only at the end of last year. So that's just a package you download and install. And boom, you've got SuperCollider. It opens up with a little text editor, and you can type in stuff, press special combination, and you can hear some sounds. Overtone.
I was going to say, I mean, I've seen. Sorry, I'm interrupting you. I was going to say, I've seen people today using SuperCollider and using the language and stuff and all that kind of stuff. So I was curious. Why do we need another language? What's the advantages of using Clojure to the language that's already available?
There's multiple reasons why we started looking at implementing with another language. I mean, one of the interesting things is there was a paper written by the SuperCollider chap, James McCartney, talking about why he thinks that other language should be explored. So he's actually, the reason he separated the server from the language was to actually enable people to explore different languages. So he was saying this is an interesting thing to do. And for us, I wanted to have at least two things. One was I looked at the implementation of SuperCollider language, and well, at the time I was a Ruby programmer, and I was very frustrated with Ruby's approach, and it had limitations of the kind of things I wanted to do musically, and so first of all, the syntax is hard to change because it's quite defined, and I really wanted to be able to manipulate it and change it and explore interesting new places. So having a Lisp allows you to really go to town with malleability. But more importantly, really, is I wanted an environment that really focused and enabled a concurrent context. Because to me, I don't want to sit on my own and play music. I want to sit with a bunch of people, all with monomes or weird devices, pressing buttons. And they're all going to be generating a ton of messages, all events, which need to be streamed and held by a server and manipulated. And so you're really in a very, very quickly in a very concurrent context. And so you want a language which provides you with good support for dealing with concurrency. And Clojure is the best language I've seen for providing that, that level of support. It's just a phenomenal language for doing concurrent programming. And so, yes,
excellent.
It's a Lisp, it's malleable, and it enables concurrency, and that's the kind of situation I want to be in. That makes any sense?
Yeah, I mean, that makes a lot of sense.
Yeah. So I went to a conference where I saw a bunch of laptop orchestra people playing some interesting sounds. And they had a distributed set of computers, all communicating to a central server, sharing states, communicating messages. So one chap would play a sequence and call it foo, then someone else would be able to manipulate foo or reverse it, so they were able to exchange ideas and play. And I asked her, this seems like a really good thing to be doing, and I wanted to start a similar, like a laptop orchestra in Cambridge. So I found a friend who was interested as well, and so we said we'll start, and we thought this was a good technical starting position. So we asked these guys how they built it, and they said it was built in Java, and asked them how long they took them to build it, and it took them about 6 months because it's quite a complicated distributed system with messages, and all this sort of stuff and concurrency issues. And I built a system which was about 70% of their functionality, so it's not entirely fair, but in one day. And that was because Clojure just provided me with all the tools. I didn't need to write much because Clojure just had it all there ready to go. So yes, it really, I think for me, I'm interested in having a vehicle, seeing the language as a vehicle to explore new territory. And so I want it to be as well equipped as possible. So for me, flexibility and concurrency are two things.
Okay, yeah, that makes a lot of sense. We've got a quick question from our IRC channel. People are asking, is this anything like C Sound? Would it compare to that?
Right. So yeah, C Sound is really one of the Music N languages. So it goes back to Max Matthews, who actually started the whole thing in the 60s. The thing with C Sound is you describe your synthesizers in the same way you do in SuperCollider, but you have to render the sound in advance. So there isn't much scope, and I think they're working on it now, for being able to interact with the sounds live. So there's no improvisation with C Sound. So it's a bit like you might render a 3D image and on a render farm and get the results back a bit later, and then you hear the results. Whereas Overtone and SuperCloud are about live involvement, where you actually are able to produce and manipulate the sounds in the same space of time. Yes, similar to C-Sound, we use unit generators, and the synthesizing techniques are very similar, but it's different, and the Overtone's focused on live improvisation.
Right, okay. And when you're working live, obviously things like latency are massively important. I mean, that's the thing I run into all the time with computer music, sound interfaces and so on, is getting the latency, the length of time it takes for me to press a button and then the sound to come out of the computer as low as possible. So how is that something you can do with this setup? Do you get a nice low latency on your performance?
So I'm able to press my mono buttons and hear a result and not actually perceive any difference between the time of pressing and the actual sound coming out. So very low latency. Part of that is to do, because we're using the JVM, we have to be very careful about garbage collection. So we don't want it to be collecting garbage whilst it's trying to actually send a message. So we can tune the garbage collector to actually do a lot of garbage collections, but a very small amount of garbage collection over time. So it doesn't pause for any length of time. And so pressing buttons and hearing a sound is absolutely fine. When you're really absolutely require something to happen exactly on a particular moment, then you can ahead of time schedule something. And so you can, Overtone allows you to say, at this time, do this event. And you can have super fine accuracy on doing exactly that. So, for example, rhythms, if you're having a beat going on, you pretty much know, it's not too difficult to know what's going to happen in the next bar. So you can just send the next bar ahead of time and have that spot on accuracy all the time forever.
Oh, that's very cool. We've actually got a special request, and we didn't ask you this ahead of time, so I don't know if this is going to work out, but is there any way you can get it to make a noise for us now, or do a very quick kind of demo sound?
I haven't set it up at all for that, because I've got my microphone.
Okay, that's all right.
Yeah, no, is the answer to that.
That's okay. That's all right. I didn't give you any warning, so... No,
so... but it feels like a real cop-out. It's like the Intel demo of the graphics card game thing the other day. No, it's the way to actually hear what's going on is either to watch the video that's on live now, so the introduction to live programming to music, or very soon, hopefully, I gave a presentation at the Closure Conference, which was really well received, and very soon that's going to be online. And that includes 20 minutes of introduction, this kind of stuff, and also 20 minutes of demos. And so you are able to see what it can do there. And if you're interested, on another show, I can come back and actually do some actual performances.
Excellent.
But yes, so, I mean, for example, you can do basic sine waves. You can do dubstep sounds. We've got integration with something called freesound.org, which is an open source sound sample library. And so we're able to, on one line, say, I want to use this resource. Because the whole thing is because you want to be able to... I think the lingua franca of music should be source code. I want to be able to send you a piece of source code and you just evaluate it and hear the sound. So if I'm referencing samples, I obviously can't, I mean, I could try and embed them in the text, but that would be daft. And so what I want to be able to do is to reference external assets like URLs. So I can say, I'm using this sound of an exploding cannon, or I'm using the sound of a laser gun that's on freesound.org, and it will automatically download and cache and be able to play that back for you without any troubles at all. So you can generate a huge broad range of sounds with this thing, and really the possibilities are endless. They're limited by the CPU power you've got and your imagination and your ability to actually design synthesized sounds. It's
so you hack this together in like a day. Are you more a programmer or a musician, or what do you call yourself if you have to label yourself?
Oh, so I hacked the example thing that I saw these other guys do in a day. Okay. So this is just a demo thing. Overtone has been developed over three years. Me personally, I'm both a researcher, so I do research at the university. So and I also have worked as a programmer in industry as well. So if you ask me to what I'm called a programmer. And I currently hack in Closure, and I enjoy that. Yeah. So
your primary interface with this, you're basically writing code to generate sound samples and manipulate sound samples. Is it more staged like that, or is it more interactive? Are you using this box with all the buttons more often than you are writing code? Or I'm just trying to get a picture of what your interaction actually looks like.
Yeah, it depends on what you're trying to do.
Okay.
So both, really. Sometimes it makes sense to just have it on the box of buttons, so you're just hammering buttons and making some sounds. And also, for example, I have an example where I have some pre-made loops. So I've downloaded some loops that some DJs made that all sound together well. So they're all in the same key and they all fit together. And then I'm able to schedule them to all be played exactly in synchronization with each other. And they'll all be played at the background, but with muted volume. And then pressing different buttons toggles the volume on and off. And this sounds very simple, but you're actually able to make quite rich and sophisticated sounds. And the cool thing is, 3-year-olds can do it. So my niece was playing it and having a really good time, making crazy, dark dubstep sounds.
It sounds like when I first discovered that I could go to a keyboard and press just the black notes and stay on the pentatonic scale, and they always would sound great together. And no matter what you did, you could noodle around and just play a bunch of the black notes and move around and back and forth, and it just always sounded great. So you can set up something like this in Overtone then.
Absolutely. That's exactly the point. So if your song only uses the black notes, why the hell would you have the white notes in your interface? Just doesn't make sense. So you would define an interface for the song you're playing. And so if you're using all the black notes, your interface would just have the black notes. And you even start to challenge, well, should the black notes be in a line? Would a circle be better, or a square? Or what's the best approach for the actual interaction I want? So you can really start to actually play around with the interface for the musical instrument you want to, so you actually start to conflate and combine interface with music-making device and composition. They're all sort of the computer, really. So you really are free to do loads of cool stuff. Yeah.
Okay, so instead of me having to start from scratch trying to write something that generates notes and tonality, you can build from a base that Overtone already provides to do this sort of programming. So
exactly.
Have you had non-programmers come at this and be able to be empowered? Even is it simple enough?
So 2 examples from that. So I have a musician friend who did his degree in music, so is really knowledgeable in music. And I don't know that much music theory. And he came over for a weekend, and we talked about music theory in the way that I asked him lots of very specific details, just like you would go to see a client, and they've got some solution that you want to build. So you start asking them about their domain, asking them about languages, getting more and more specific. I was doing exactly the same approach, but understanding about music theory, and then just writing it up into closure code. So now in Overtone, we have a whole full namespace full of Western music theory, and scales and arpeggios and chords and different tuning mechanisms. It's very rich. And so suddenly, now that's codified, it affords a whole load of cool stuff. So I can now read that code to refresh myself how it all works. And it's so much easier reading code which describes music theory than it is reading a music theory book. And it also means that you can then take advantage of the code I've written, which is a remarkable thing. And then the other example was I was giving a workshop in London on Overtone, and a lady came along, and she didn't really program very much, and she just heard that it was a music thing and programming, and she wanted to know what it was all about. And so it's a hack day, hack evening for professional programmers who come along. So it was quite surprising to see this non-programmer there. And one of the cool things you can do is there's an application called TouchOSC. And OSC stands for Open Sound Control. So it's the messaging protocol we use to stream events from process to process across servers or into the machine. And so this allows you to define your own interfaces on the iPad. So you can put sliders or toggle switches. And then when you slide them, it sends events over UDP or TCP. You pick it up and you handle them. And so these people are split into this group. So I actually walked into their group just as they had connected the TouchOSC interface with a weird dubsteppy, grungy synthesizer sound, and it was controlling the wobble factor. So it was like whoa, 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 whoa. And it was amazing. Her face was extraordinary. You know, she because there's one thing to hear computers make weird sound, but it's another to actually control it with your fingertips. It really has to be, you have to have a go to actually see how enjoyable it is. And so the whole point is, the premise is that it's just a lot of fun. So they actually ended up doing a performance of Twinkle, Twinkle, Little Star in dubstep style. Well, one of them was actually controlling the melody, and she was controlling the wobble factor. So they actually were able, in 2 hours, or an hour and a half, to create a composition, to put it all together and make a performance. And that for me was such a rewarding experience to see.
I was just going to say that sounds like, it's amazing when you can have something that has this much power to individuals to be able to effectively express themselves in an entirely different medium like music.
Exactly.
What is that like, watching that happen over and over? Do you like the sort of the eyes twinkling as not to pull reference to your past song, but like, what is that like for you? What is it like for you to keep seeing that over and over?
It's a remarkable thing. So programmers spend a lot of time learning how to program in order to build software for companies. Typically that's what we typically do. And so we're interested in how can we create solutions faster, more optimal. How do we maintain these things and to test them? And it's all interesting, but really that's not what we want to be. Well, that's not what I want to be doing in my life. I want to be making cool music or hanging out with my friends, having a nice time. And so being able to combine the two, to be able to use my programming skills to actually affect the real world that matters to me, so that I'm able to sit and play some music to my wife or to my friends, and then to say that's really cool, it's a remarkable thing. And I guess the analogy is like cooking. So I could go around to your house and you could cook me a nice meal, and maybe it's not Michelin star quality, unless you're a genius chef, but the chances are you aren't. But that doesn't matter. It's more a social thing, and we'll be talking about how you cooked it, what the recipe was, and where you bought the ingredients, and it'll be a nice thing to do. And we don't do the same with music. So we just buy in fast food. It's like, I read an article talking about there's a city in America, or maybe it's true or not, I don't know, I hear a lot of rumours, where there's a lot of houses don't have kitchens anymore because people go out to eat fast food all the time or to eat at restaurants. And to me, that just the idea of not having a kitchen in your home is tragic. And so, and the situation we're in now with music, we only have music consumption devices. We have a stereo which plays back the radio, or plays back an internet stream, or plays back a CD. Not that many people have instruments in their homes anymore. And so I think it should be more like sitting around and having a meal together. It shouldn't be about listening to the best music in the world or going to the best restaurant in the world, although that's a nice thing to do occasionally. It should be more a social interaction of let's sit down and jam together and play some cool songs. And so I think Overtone gives people the opportunity to do that. And when they actually feel that their programming skills and a bit of an interface can make some weird sound and they enjoy it, it's just an extraordinary thing to watch. And it's very, very, very rewarding. And I hope to see it more and more. Yeah, it's wonderful.
Well, I see a parallel analogy to the whole open source movement that, that we have been, in the old days, everybody programmed. Everybody, that was involved with the computer program on some level, I suspect. But then there was a whole new batch of people called users that kind of took over from there and started using the software, but didn't have any idea of how to get under the hood, as it were, and manipulate things down. And so this seems to be more of the getting the music side of it brought back into the hands of common people like me, because I dabbled with keyboard all my life, both for programming and for just playing music and stuff. I always had an organ around the house when growing up. So I'm already excited by this. I'm already I want to go start playing with this now and watch the video you talked about and things like that. So, but will this won't turn me into a great musician, will it? I mean, or is that still somewhere in between? The
example I have here is I read this really interesting article by Garry Kasparov, the chess player. So he was like a world chess player champion, and he famously lost out to computers. So he lost in the famous battle against Deep Blue, the rematch. And so what do you do if you're a grandmaster chess player who used to be the best in the world and suddenly you're defeated by computers? What's the thing you do? You team up with the computers. So he created something called advanced chess, where you would sit with a laptop and you would play chess with your grandmaster friend who also had a laptop. So essentially you cheated. And it's interesting that although computers now can beat humans, computers plus a human can always beat a computer. So the cyborg approach is currently the best combination for chess. And then what was really interesting is they had open chess tournament where anybody could submit any moves however they wanted online. So usually they have heuristics to actually determine whether someone's cheating or not. And so they turn them all off. And so Kasparov had practiced playing chess with his computer and with his friends for a while. And so he's obviously a grandmaster, extremely good chess player, using computers. He's really confident he's going to win. And two random guys from America just trounced everybody. And it was a complete shock and surprise. And so it turned out that they just built some cool software that gave them better choices, and they were able to actually, I think, maybe actually see about 5 different options on the screens and have a better selection. So they were essentially, they had a better process than Kasparov, which then Kasparov then had a thought that maybe a strong human plus a weak process is no match for a weak human plus a strong process. So although he was the best chess player in the world, or one of the best, he was able to be defeated by someone who wasn't as good because they had better software. And so I think this works beyond chess. I'm betting that it works beyond chess. And I think that if you can introduce strong process, as in cool software that does cool stuff, like a very interesting namespace full of music theory, you can empower people who aren't necessarily strong musicians to become very good musicians. So I don't necessarily agree. I think actually the goal is to actually empower people to a greater extent. And what perhaps you might have had to spend 10 years practicing to do, someone can write a piece of software to actually emulate that, and then you can just take advantage of it. And so, for example, I have a piano piece by Eric Satie, which I've programmed into Overtone, and I can play it on my monome. But I haven't done it in a way you might imagine. I haven't mapped all the keys on the keyboard, or the piano keyboard, onto buttons on the monome, and learnt where they all are, and play them one after another in the right order. Instead, I have a string or a sequence of notes which are the left hands, a sequence of notes which are the right hands, and then I have an index into both of those, 2 separate indexes of which note we're currently at. And then I have a button for the left hand and a button for the right hand, and I choose when to play the left and the right hands. And so it automatically plays the right note for me. And what I focus on is the timing. In fact, actually, I have a row button so I can change the volume as well. But if you think about it, what is the difference between 2 good piano players on stage? It's not that one is able to play the piece and the other one makes mistakes. They both play the piece in terms of the actual notes to play perfectly. The difference is their timing often, or the sensitivity of the notes. And so if you can abstract away or simplify the actual making the error of which note to play, so in this case, I can't ever play the wrong note because I'm always playing the right notes, I then can just focus purely on what's interesting to me in this case, which is the timing of exactly when to play it. So in this way, you actually start to simplify your interface for the particular performance you're trying to make, and that can empower you to a greater degree than what would be typical with a standard interface for music. Does that make sense?
Yeah, it makes sense to me. Great. I never thought about the chess analogy. That's a great answer as well. So if we can get into a little bit of the kind of technical side of it, I suppose.
Of course.
We've already done quite a lot of that, but I'm curious. It's all based on Java, right? So is that all I need to run this? Is just to have a working installation of Java on whatever machine I'm on?
So there's two separate things. So we're using the SuperCollider server, which is actually a C++ application. And so either you can install that by downloading it like you would normally install it, and then we can actually we know where the default paths are, so we can launch that directly. We also ship currently, although this might change in the future, some pre-compiled versions of this in a jar file, and then we're able to dynamically launch those as well. So that for Macs that works very well, and for Linux as well. For Windows it's a bit more tricky, but we have to try and compile for all architectures, and so we don't have binaries for all architectures. So that's one hand. We've got SuperCollider. Either you install it yourself, or we might provide you with some pre-compiled binaries, and then you need a JVM, and we don't actually use any Java per se. It's all enclosure, but it still compiles down to JVM bytecode. So if you can run Java on your machine, you can run Overtone. So there's just 2 things you need. So if you've got a Mac, for example, it just works out of the box. If you've got Linux, you just need to install. We've got very detailed install instructions. You just install JVM on your machine, and you're good to go again. And same for Windows. And we support all 3 platforms.
Excellent. I mean, I was going to ask if you've thought of some kind of live CD or something that people could kind of boot up and it would all just work. But it sounds like it's fairly easy anyway on most platforms.
It's easy if you're a programmer. So
right, okay.
That's the caveat. So I started off actually with this. For my part in Overtone was to try and consider how we might create DSLs or MIDI languages or MIDI interfaces for normal musicians to become more creative by using computers. And the more deep I got into the problem, the more I realized actually it should be the other way around. That musicians should be actually more aware of programming than trying to make their lives easier. So I actually believe now that a very important future for musical notation and musical interaction is through programming, explicitly programming. And so I don't mind so much right now that our audience is primarily interested programmers. And so it is a bit like a dev environment. You do have to set up a developer's... I mean, I'm using a terminal, you know, we are working on some GUI components now for sliders and widgets and things, but primarily it's a text terminal-based interface. So you have to be familiar with the terminal or familiar with tools like Emacs and Vim. But if that's who you are and you've got the computer skills, then you've got an amazing experience ahead of you.
Okay, and it seems to me that you were saying about the whole idea of kind of getting together with your friends and being able to, you know, just make music, even if you're not maybe a virtuoso or something. It seems that at the moment there's quite a barrier there. You need to have quite a bit of technical knowledge. I couldn't say to my dad, go and try this and you'll be able to make some music. I'd have to set it up for him. So, and the other thing is, you know, about getting musicians and things. Is that a long-term goal to make it easier for, say, the layman to use this? Absolutely.
Once we have applications or modes of interaction that really work on their own, there's no reason why we can't start to package these up. It's really just a matter of polishing things and getting the manpower to do that. So yes, I completely agree. But right now, it's the current mode is for exploration. And so what we're looking for is more people to get involved in the community, to write more open source music, to share that music with other people. And that music could just be compositions. The people now, actually on the mailing list just earlier today, have been thinking about new ways of actually notating rhythms. So it could be at that level of abstraction, or you could be really interested in making new weird sounds. So you could be designing new synth sounds for people to actually use in their compositions. So there's a whole spectrum, there's a huge vast array of options you can use to find where you're interested in and get involved. And the whole idea is to build a library of cool sounds and cool synthesis techniques and cool abstractions that we can then use to actually to raise the water level for everybody, to make it easier to be more musical. Sorry. So,
well, I mean, it could be music. It could be anything, actually. It sounds like you could use this to create maybe soundscapes for backgrounds for videos and stuff, right?
So if we want to start talking about what is music, yes, absolutely. Just sounds, cool sounds that you could describe as music or you could describe as backdrops. So yeah, audio experiences per se.
Is this thing ready for prime time? Can I just download this and start experimenting with it now? I mean, you said it's been around for 3 years. So I'm wondering what stage in the development cycle is that? So we're pretty technically sound now. It's a highly complex thing. There's lots of moving parts. So and the SuperCollider doesn't really provide you with many safety nets. So you can crash SuperCollider, but it will just blow up the process and you have to restart. That's the worst that can happen. I mean, we've actually built in a lot of safety features that SuperCollider doesn't even support itself. So, for example, one of your instruments you could say is a sine wave. Okay. That normally oscillates between -1 and 1. So at how many frequencies per second. Now, if you then multiply that by 2, it goes between -2 and 2, and that's a louder sine wave. So you could, 4 months ago, you could say, multiply by 1,000 my sine wave. Ouch.
And it would, and you throw your headphones off, you feel sick for 3 hours. It's like some sort of nightmare. It's like some sort of torture treatment. So you could do that kind of thing before, but now in Overtone we built a safety system so that can't happen. So you can't destroy your ears, you can't destroy your sound system. Well, certainly I've tried to destroy mine, and I'm not able to. But you can. The process might blow up occasionally, but that's the end of not the end of the world. And so it is ready. For you to experiment and work with. And if you were to play with it and you were to get involved, then your ideas would be very well received, because we want to be able to work out, because it's not just a language, it's not just a framework, it's not just a tool, it's sort of a suite of things. And so the cool thing about Clojure as a language to work with is you can easily build discrete components that can work together nicely but don't affect each other. So it's not like a language like Ruby, say, where if I import this module, it suddenly redefines true and false for all objects in the system. You know, that can have all sorts of weird side effects. Because the language by default is immutable and things don't change, I can safely pull in another module and I know it won't affect what I've got there already. So it's a good environment to actually experiment and try a multifaceted approach to exploring music synthesis. So yes.
So I could download this today and start playing with it. Now, if I wanted to help improve it, I need to know programming in Clojure then, obviously. And what other
Yes.
skills should I need then in order to be able to contribute back to the project?
Well, my friend Marius, he didn't know any Clojure at all. He had a minor amount of programming, and he contributed by suggesting or describing music formalization. So he was able to describe what scales were and what tones were. And so if you've got musical skills and new programming, you can join the mailing list and say, this is how jazz improvisation works. This is how we move from this chord to this chord, and this is why we do this, and this is the constraints we have in a typical piece, for example. That's so if you can formalize those things in language, English, that's perfectly fine. If you're a Clojure programmer, then you can start to actually get inside Overtone and work on, because it's a very interesting, it's 20,000 lines of Clojure code. It's a very interesting concurrent, message-based, callback function system. Lots of interesting moving parts going on. Lots to get involved with. So if that floats your boat, that's cool. If you're interested in making new sounds, you can design new synth sounds. If you're interested in making new kinds of notations for rhythms, it's what people are doing on the mailing list right now, you can get involved with that. And you don't need to program to do that. You can say, well, I don't think that notation looks very good because I can't express rests here, or I'm not able to actually see multiple rhythms at the same time. I think this would be better. So I don't think you have to be a specific skill. I think what's more important, and the thing I keep trying to stress to everybody, is that it's fun. So if you are tinkering around and playing some weird saw wave things and you're enjoying it, that's what it's all about. No more than that. And once you're in that environment where you're having fun and you make something which sounds a bit weird and a bit interesting, you might think, well, compared to my favourite artist, this really sucks. It's rubbish. It's not polished or anything. But that little piece of source code you've written is like a special golden gem that you should share with the world, because they might not know how you made that, and they might be able to look at that thing and learn from it, and to discover new things that you perhaps thought were obvious. Other people might see as new, exciting possibilities. And so what you can do is you can actually have a play, make something weird, and just put it in a gist on GitHub, or email it to the mailing list, or make your own project on GitHub if you want, or whichever means, and just share it with the world and say, this is how it works.
Wow.
And this is how you can play with it. And there are a bunch of gists. So, we have an Overtone Twitter account, and I'm often tweeting little mini gists that people have made. Like, for example, someone synthesized Troika, so the Christmas song, dum da 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 dum 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 da dum, and she started off by actually describing the bell sounds using pure synthesis. So there's no samples, pre-recorded samples. So this is how this is what is in a bell synthesis, and she linked to books she'd read to actually do that. And then she wrote a score in Clojure keywords, and then mapped that onto actual MIDI notes, and then played it through using a mechanism to actually choose the next note, know when to play it, and send it off. And the whole thing is about 100 lines of code. It's very small. And so she gisted that. So now that's available for you to have a look at. Oh, that's how I can make bells. Oh, that's how I can make a little song. I can play around with this. I can change the tempo. You can start to play around with this. And so there's if you're interested in examples of music, then there's the Clojure podcast. So Chaz Emmerich is doing a podcast called Mostly Lazy. So it's mostly about Clojure things. But one of the cool things about that is he's actually using Overtone sounds to as intros and outros to the podcast. And so in the show notes, he always links to the source for the sound. So if you hear something cool, you can think, how does that work? And you can actually look at the source, which is the way forward.
That's an incredible sharing, incredible way of actually bringing out the musician that's sort of inside of all of us, it sounds like, especially us programmers. Absolutely. For sure.
Because I'm not a very good musician. And so I want to actually have people who are better musicians teach me through the medium of Overtone. So I find it's an amazing environment to actually learn very quickly. So there's a guy who's in my labs who's a really, really very good musician. And he said to me, how long have you been a musician for? And I said, well, I've only been doing this, really focusing on this thing for about a year now. He said, no, he couldn't believe it, because I was able to speak to him in his language, because Overtone helped me learn it much more fast, much more rapidly. And so this is the thing. So if you've got some cool musical techniques, you encoded them to Overtone, I can learn them rapidly. And that's very empowering for me and for everybody, because we're raising the water level for everybody.
Well, we're just about out of time. I'm just wondering, is there anything that we forgot to ask you that you really want to make sure our audience knows before we have to let you go?
I don't think there is. I think that no. So I don't really. I'm not trying to sell anything or market anything. I'm just saying if you're a programmer and you're interested in having the experience of feeling musical, so it's not just about listening to music, but you want to actually have a go at making some music, then have a play with Overtone and be amazed by how engaging and fun it is. Just to make the simple sounds, and not to worry about whether the sounds you're making are polished and professional, just to worry about whether they're fun or not to actually to work with and enjoy. Because I want programmers not just to think, how can I improve my programming skills for a work environment? I want them to also think, how can I use them to actually to express myself in more interesting ways? And actually, it works in reverse as well, because I mean, people say, well, musical context not very interesting for programming stuff, but actually, the kind of questions you have to ask of programming languages and environments and concurrency and timing actually are really deep-rooted computational questions. And so getting involved in something you're passionate about and you explore very quickly makes you learn deep computational things that are actually skills that can work in the workplace very well. So how do you build a distributed messaging system? Well, you need one if you want to actually play a monome on an iPad and transfer the messages across to another computer to actually play them. You need to be able to stream events. And so it's much better to actually, I think, it's much more fun and more interesting to build that system for musical goals than just to say, well, I've just sent hello world and it's appeared on my screen over there. You know, to actually press a button and hear the bong on the other side. That's
similar to the notion of, you know, the old Tinker Toys or Lego, where we would actually build things and play with real things, and in the process learn about the construction of things, because we learn you have to build a wall by putting up a bunch of layers, and you have to build a roof in order to have a roof over your head. This is doing the same thing with music then.
So I was teaching my friend Closure he has a monome as well, by giving him very simple tasks. So the first task was, plug your monome in and make all the buttons light up. So I have an API to do this. And so he did that. And then the next task was write a function handler that when you press a button, it's printed on the screen, a button's being pressed. You know, and so by expressing very simple tasks, you're able to actually get somebody to learn a language quite rapidly, but in a very engaging way, because they're not just writing a Fibonacci sequence, you know, or printing hello world. They're actually lighting buttons up on a device or making sounds. So I think as a learning environment, Overtone provides a really interesting opportunity to teach programming, or to even give people new experiences in programming that they wouldn't have normally had.
Sam, it's been absolutely wonderful chatting with you. You've been a great guest. Really, I'm excited. I'm now angry at you because I now want to go play with this all the rest of the day, but I've got a client to deal with today. So,
can you express your excitement in a facial expression for me? What is it? Wow. What's your excitement? Oh, that's pretty good. Thumbs up. That's great.
For those that aren't watching the video, I put 2 thumbs up and I smiled right there. So that was the good thing for that. Sam, really, we're out of time. I'd ask you like 6 more questions. It would take another hour to get through all the questions for that. But I encourage people now to go to your site and check this thing out and really take a look at it. So, Sam, thank you for being on the show.
Very welcome. It's been a complete pleasure and delight. Thank you so much for having me.
Very good. That was Sam Aaron, who's been one of the chief core contributors to Overtone, a highly expressive closure front end to the state-of-the-art real-time sound synthesis server super collider. So, Dan, what do you think?
Yeah, I thought it was fascinating, and I think Sam's got everyone fired up, even in the IRC there, which, as I was saying, is slightly difficult sometimes. But yeah, I like this idea of pieces of music being like pieces of code and sharing them and stuff. That sounds very, very cool. I can't wait to see a Git repo for a new song to pop up or something.
Well, yeah, I mean, it's like I learned music because I really enjoy the performance of music. You know, I still do karaoke frequently, like at least every other week or so, and I still like being in front of an audience, delivering some sort of thing that makes me feel good at the same time as making them feel good. And I'm finding this fascinating. I'm not kidding. I want to quit what I do the rest of the day and go play with Overtone for a while. But I know I can't because my client's sitting right over there. So I have to be very careful here about what I'm doing today. But yeah, no, this sounds really great. I'm really glad we had Sam on for the show to talk about Overtone. And I hope I encourage all you guys listening at home or wherever you're listening to this, in your car or whatever, to when you get a chance, go check out Overtone. It's really cool. Speaking of upcoming guests, my awkward transition musician for the week. We've got a surprise guest for next week, which means I haven't finished booking them. Hopefully there'll be somebody for next week. But after that, we've got David Skoll. I'll talk about the Remind project, which is a to-do list manager. Should be really cool. David Carver and Sastri Maladi. I'll talk about Turmeric, which is a big application made open source by eBay. And I keep remembering I'm supposed to go look and figure out what that's about. And I keep forgetting, but there we are. Anyway, so you go check it out. Go look at the URLs on our upcoming list. And David Merz, the Vegas security tester, and a bunch more on the short list. Go to twit.tv/floss. There's a spreadsheet list linked from there that will tell you about what's coming up in our upcoming list. You can also follow us at Floss Weekly. That's Identica and Twitter handle. So you can see, like, for example, what today's guest was going to be, or when I book new guests, I try to tweet that right away. We have a live chat room, as you heard about this. Normally we tape at 9:30 a.m. on Wednesdays. West Coast time, so you can come in and chat with our guests through us. You can also follow me at Merlin, M-E-R-L-Y-N, on Twitter and Identica, although I don't do much on the Identica stuff. If you were following me, you'd also know that this week I am in Daytona Beach, and I'll be hanging out at various places today and tomorrow here. Actually, Daytona Beach tonight, Orlando tomorrow, and Fort Lauderdale on Friday. So it's going to be a little bit of a Southern California. What am I talking about? Southern Florida. I'm on the wrong coast for that stuff. All right, anyway, so follow me there, find out what I'm doing, and I'll be on a cruise next week, so you'll probably see some cruise-related tweets from there. Again, if you want to have somebody on our show, like many of the past guests have been on our show because of people like you listening, basically have the project leader email me, and I will put them on the list. Dan, what do you want to plug today?
Well, obviously, I'm wearing my Linux Outlaws T-shirt, so actually, I've obscured it a bit there. Sorry, I'm getting bogged down in the video. So I'd encourage people to check out Linux Outlaws, which I'm one of the hosts on. It's a weekly show about open source stuff. Linux, obviously, is in the title, but not just Linux. We also talk about other stuff as well, anything free software, open source related, all that kind of stuff. If you head to sixgun.org/Linux Outlaws, you can find out more there. And also, if you want to follow me on Identica, Twitter, all those kind of places, Google+, you need to go to danlynch.org, which is my website, and you'll find all the links on there. So go and check it out.
And I do want to say we actually do have a Floss Weekly Google Plus thing now, but and it just recently got to the point where it opens up so that you, Dan, and I, and the other co-hosts can all actually post to it and manage it. So I'm going to set that up in the next couple of weeks. So we'll be watching for the Floss Weekly page to actually start lighting up finally on Google Plus. I'm also on Google Plus. I'm everywhere, all over the net. Just Google for me and you'll find me all places. I follow from my Wikipedia page. You can go all the way down to every other place that I pretty much have. So that's great. So Dan, once again, thank you for being on the show, especially when it's music related like this. I really appreciate you being on the show with me with this.
No problem. It's always a pleasure, and I'll speak to you again soon.
I'm sure you will. And so I hear the music coming up, so that must mean it's about time to say that what I always say right here at the end of the show, which is we'll see you again next time on Floss Weekly.